The topic for Lesson 8.4 is all things rectangle. You will recognize and apply the properties of rectangles and determine whether parallelograms are rectangles. How are rectangles used in tennis? Many sports are played on fields marked by parallel lines. A tennis court has parallel lines at half court for each player. Parallel lines divide the court for singles and doubles play. The service box is marked by perpendicular lines. A rectangle is a quadrilateral with 4 right angles. Since both pairs of opposite angles are congruent for any parallelogram, it follows that it is a special type of parallelogram. Thus, a rectangle has all the properties of a parallelogram. Because the right angles make a rectangle a rigid figure, the diagonals are also congruent. Theorem 8.1.3 states if a parallelogram is a rectangle, then its diagonals are congruent. Here we have a chart that summarizes everything you'd ever want to know about a rectangle. The definition, a rectangle is a quadrilateral with 4 right angles. And we just said for Theorem 8.13, opposite sides are congruent or parallel. And then using the properties of a parallelogram, opposite angles are congruent, consecutive angles are supplementary, diagonals are congruent and bisect each other, and all 4 angles have to be right angles, since if they're supplementary and one is 90, the next one's going to have to be 90 as well. Example 1, quadrilateral RSTU is a rectangle. If RT equals 6x plus 4 and SU equals 7x minus 4, find x. Well, we said that the diagonals are congruent, so we can solve 6x plus 4 equals 7x minus 4, and we'll find x. So we can subtract 6x from both sides. So 4 equals x minus 4, and add 4 to both sides. And so we're going to get x equals 8. For the next example, if we know we're starting with a rectangle, we know that all of our angles are right angles. So when we go to find x, 5x plus 8 plus 3x plus 2 must add up to 90. We don't know that it bisects the angle this time, but the sum should be 90. So 8x plus 10, combining like terms, equals 90. I'm a step ahead of myself. Subtract 10 from both sides. Hello, there's my 80. 8x equals 80. So x is 10. Now to find y, if we have a rectangle, we know that opposite sides are parallel, so that means that alternate interior angles must be congruent. So 6y plus 2 equals 3x plus 2, but we know that x is 10 because we already found it. So 6y plus 2 must equal 32. So 6y subtract 2 would be 30, divide by 6, so y is 5. When would you ever use this? Well, this is a real construction method. Kyle is building a barn for his horse. He measures the diagonals of the door opening to make sure they bisect each other and they are congruent. How does he know the corners are right angles? Because a parallelogram with congruent diagonals is always a rectangle. And that's stated in Theorem 8.14. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Quadrilateral ABCD has these vertices. Determine whether ABCD is a rectangle using the slope formula. So using the slope formula, we should find that the AB is parallel to CD, their slopes are the same, and AD and BC have the same slopes, and those slopes should be opposite reciprocals of our first set. To find the slope of AB, we do change in y over change in x. So 3 minus 1 over 4 minus negative 2, so we get 1/3 for AB. For CD, negative 2 minus 0 over negative 1 minus 5 is also 1/3, so that's good. The slope of BC is change in y, 0 minus 3 over change in x, 5 minus 4, so negative 3. And the slope of AD is 1 minus negative 2, so 1 plus 2 over negative 2 plus 1, so negative 3. So as we hoped, we have opposite sides with the same slope, and consecutive sides are opposite reciprocals. So this would be a big yes. Now we've answered the question the way they worded it, but they could also start off with the same question and ask us to use the distance formula. So I'm going to keep going, reworking the problem that way so you have an example both ways. So if we use the distance formula to find the length of AB, the difference in the x's, ooh, they got a problem with their parenthesis there, would be 4 minus negative 2, so 6 squared is 36, plus the difference in the y's, 3 minus 1 squared, so 2 squared is 4. So we have the square root of 40 for AB. To find DC, we have the difference in the x's squared plus the difference in the y squared. So 36 plus 4 is also the square root of 40. That's good. And we're still going. We're finding the length of all four sides. So AD, difference in the x's squared is going to be 1. Plus difference in the y squared, negative 2 minus 1 squared is 9. So I have the square root of 10. And finally, for BC, the difference in the x's is 1 squared is 1, and the difference in the y's is 3 squared is also 9, so I get the square root of 10 again. Woot woot, opposite sides are congruent. So we've just found a second way to show that the quadrilateral is a parallelogram. But wait, there's more. Only write down one of these methods. But the third way we could do it is to check the length of the diagonals. AC is the square root of 50, and wouldn't you know, so is DB. So now we have found a third way to answer the same question. They will tell you how to do it, but there are 3 different ways we can confirm that this guy is a rectangle. Here you thought you knew all there was to know about rectangles in kindergarten, but we found out that a rectangle is a quadrilateral with 4 right angles and congruent diagonals, and if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle.